In this question, a man running horizontally on a road at 8 km per hour finds the rain falling vertically. He increases the speed to 12 km per hour and finds the drops make angle of 30 degree with the vertical. Find the speed and the direction of the rain with respect to the road. So this entire question can be divided into two cases. First case will be for when the speed of the man is 8 km, and the second one will be when it increased to 12 km. So let us divide it into two cases. Case 1, okay, so it's given that horizontal speed of, rather I can say velocity because it is directional, horizontal velocity of the man, let us represent it by Vm1 in x direction because horizontal is given as 8. Now it's given that man finds that the rain is falling vertically. Okay, so we can write same man find that rain is falling vertically. So it's falling vertically, then we can say that the relative vertical component of the rain with respect to man in the horizontal direction is 0. Okay, we can say that relative velocity component of rain with respect to man in horizontal direction will be equal to 0. Okay, so we can say that relative velocity of rain with respect to man 1 in x direction will equal to 0. Okay, so we can expand the formula. We can say that relative velocity of rain in x direction minus velocity of man in x direction will be equal to 0. From this you can say that velocity of rain in x direction will be equal to velocity of man in x direction, and that will be equal to 8. Okay, now case 2. The man has increased its velocity to now 12. So we say that horizontal velocity of man, okay, horizontal velocity of man, and let us say this is m2 and this will be given as 12. Now in this case rain makes an angle at a angle of 30 degree with the vertical. Okay, so we can say that rain makes an angle of 30 degree with vertical. Okay, so from we can see that angle be theta, so theta will be equal to 30 degree. Let the angle be theta, so it will be 30 degree. So let's draw. So this is a vertical and rain is making an angle of theta with this vertical, so we can divide, let this called as VR, two parts. Okay, so this will be horizontal Vx and this will be vertical Vy. So now we find out the relative horizontal component, same which we did in the first part. We find out relative horizontal component of velocity of rain with respect to man. We can find out this will be equal to VR M2 in X will be equal to VR in X direction minus Vm in X direction. So we already found out that this velocity is 4 minus 12. Okay, so this will be coming as 4 minus 12, sorry, 8. 8 minus 12, this will be equal to minus of 4. Okay, now we are going to find out what will the angle. So we will say that angle will be equal to tangent of theta. So tangent of theta will be equal to Vx divided by Vy, and we can see that tangent of 30 degree will be equal to Vx is 4, we already found out, and Vy we are going to find out. So we write Vy is equal to 4 tangent of 30 from here we get Vy is equal to 4 root 3. Now we find out the resultant velocity of the rain. So we write resultant velocity of the rain, that is equal to Vr, we get Vx square Vr square and it square root. So we know both the values. We get this as 8 square 4 square, this is equal to 64 plus 16 I missed 3, so this will multiply by 3. So this will be 64 plus 48, and it will be equal to 12 VR will be equal to square root of 1112, or we can say VR is equal to 4 root, this will be 16 and 7. Let me check it. 16, 7, yeah, 4 root 7. So this will be the resultant velocity, and let us say that let this makes an angle, let alpha be the angle rain is making with the vertical. So we get tangent of alpha is equal to VR divided by VRY, that is equal to 8 divided by 4 root 3, and this is equal to 2 root 3, or we can say alpha is equal to tangent inverse of 2 root 3. So this is the angle with respect to which it is making with the vertical. Thank you.